Oh, am I just gonna implement some ray intersection? I guess I could just compute a line going to like from the center to the origin and intersect that with the three triangle points. And there's already a line intersection algorithm here. Line intersection returns intersection point of two lines, each defined with a pair of vectors determining the endpoints. Oh, and there's a get winding number. Get winding number of points. There's a shoelace algorithm. Okay, I think I'm gonna end up doing the line intersection. Why does this raise a value error? Like, no, I guess that's a good thing to do. That makes sense. Okay, so here's what I'm gonna do. If point inside triangle then I'm gonna choose its color. Fill color. We could say white. There we go. Okay. This should just make them all black. Oh, fill color should be fill color. Okay. Okay, nice. This actually makes me think I can turn the side length down a tad. Okay, yeah, this is fine. Although my GPU is really feeling it. Which, to be fair, I am asking for it by rendering this background. Also, I shouldn't be printing. I'll need to do that. Okay. So the triangle is a polygon. If I search the polygon, OpenGL polygon. Okay, then I can do get vertices. Okay. Oh, where? Okay. It's gonna be 3 lines. I could say 4 I in range. 3. Get the triangle points. Was get vertices, right? Yeah. Wonder if I did this. That would help. Yeah, that helped out. Yeah, and this is a NumPy array. Triangle lines, triangle points equals this. Triangle lines that end a tuple. It's going to be triangle lines that end a tuple. It's going to be triangle points at I and triangle points at I plus 1 mod 3. All right. And with that, maybe I'll just print out triangle lines. Wow, that is a lot of points. They look right, though. I think. Yeah. Yeah, okay. Cool, cool. Then I'm gonna take a line from the point to the origin. And this will be a tuple, since I think this takes tuples. A pair of vectors. I guess I didn't say. I'm assuming pair means tuple. Let's just be point, origin, very straightforward. Actually, get vertices. What is get start anchor? Whatever. I'll just say that myself. Then I'm gonna want to look for the line intersection. Try. I guess I don't care what the intersection is. Or I'm gonna have to see if any of them works out. That's what I'll have to do though. So it'll be this way. Or line in triangle lines. Mm-hmm. 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 I'll start end triangle lines. Try line intersection. Oh, I guess I will want the line. Point to origin, then triangle side. I'll accept the value error. And this means there's no intersection. And if I get this far, I'm going to say intersects equals true and then break. Set value error, I guess do nothing. Then I'll say if intersects. That means it's outside the triangle. So return false. And it's like else return true. Okay, that was a lot of code to actually be right at once, so I doubt it all is. This is return not intersects. Well, I guess that didn't work. I'm gonna print black here, I'm gonna print white, let's see which of these is happening. I guess they're all getting white. Happening. I guess they're all getting white. So for this to be true, intersects have to be false. Intersects would have to be false, so the intersection would have to fail. So line intersection is always doing a value error, I guess? Let's see if this ever prints. I wasn't trying to do that. Yeah, it does a few times. I wonder if this scope... I think what I want to do is here set this to false. You go each of these. If you find an intersection, then it's true. And it's inside if not intersects. Okay. So let's see. Okay, so it intersects and then it says false. Is that ever true? It's never true. Intersects, then point inside is false. So I guess it never gets 3 value errors. And that's weird. It should be centered on the origin. So why would that happen? Say num errors equals 0 here. Num errors plus equals 1. I'm gonna print that. See if this ever reaches 3. No, it's not 0, in fact. Well, don't understand that. Lines do not intersect. So I guess the determinant of this is never 0? Oh, it must be not doing line segments. It's doing the line. That's annoying. Okay, so that means this approach never would have worked in the first place. I thought this was doing intersection with segments. What's a better way to do this? Maybe I will have to do just a simple ray intersection thing. Well, that would require the number of intersections with it, which this doesn't do as far as I know. Well, it can't do because it only returns one thing. This does or array of intersections. I think that's not actually enough. This is going to be a pain. What's the computation that I want to do? I guess I could just have a normal, which points toward the inside of the triangle on each of these sides. Then after I translate like the midpoint, which points toward the inside of the triangle on each of these sides. Then after I translate like the midpoint or something, if I translate part of the triangle to the origin, part of the side to the origin, that dot product should always be positive, right? Still a huge pain though. It's too bad we don't just have an algorithm for this out of the box somewhere. Triangle lines, triangle points. There's the lines. I'm gonna get the normals. So I'll have this. Now what will I want here? The normal is going to be a direction. And if I had x, y, it'll be the opposite of y, x. I think. But these aren't positioned at the origin. Does that matter? I guess I can always do this. Take this, negate one of them, switch them. Like so. This will do the same thing as before. I think all of this code won't help me. Now add an arrow. It's gonna be star, triangle normals, -1. I'll do that. Move to triangle lines at -1 at 0. Maybe this will show me something useful, or maybe it'll crash. Yeah, that sounds about right. Let's try it like that. Well, those are certainly some directions. They don't make sense to me. Now, it could be the case that I just didn't do this correctly. Like I should have done this. No, that doesn't make much sense either. Okay, I gotta figure out how to rotate points. 2D rotation. My 90 degrees should just swap one of the coordinates. Okay, so it becomes negative yx. So I had it the first time. So the difference has to be that I have to translate it to the origin first. So I have this start point, this end point. I actually gotta save those separately. So I have to do start. So I have this start point, this end point. I actually gotta save those separately. So I have to do start. It's this, the end. It's that. So that's a line. I'm going to have to add the negative start to both these points. Or I guess just to the end. I should actually, this is a good opportunity to write down what I need to do here. Because there's ending up being a lot of geometry here. If I can manage to pull this out. Ending up getting a lot of geometry here. So if I have this triangle, and I can just do this for one side, I have a start point, end point. And I want this vector. Then how can I get that? Well, I can get this vector easily. I already have the start and the end point. This is just t minus s. It's this arrow. Since I get t minus s. Oh, I wasn't getting t minus s though, was I? Once I get t minus s, then I can just take xy to negative yx. And that should rotate at 90 degrees, but rotate at 90 degrees in which direction? This is counterclockwise. So that would give me the wrong vector. Okay. With xy. So basically what happened here is I swapped the two. Then I made the x coordinate negative. So to go the other direction, I'd have to still swap them. Then would I make this negative again? Well, that's the same thing, so that can't possibly be right. It'd have to be something like this to go the other direction. Yeah, you would do this one. Okay, so I'm gonna try that. Wish me luck. Okay, so the vector? Aqua beam, what's going on? You're lucky, or I'm lucky you didn't get to see me messing up math. Okay, so I'm gonna do n minus the start. Is the vector in the direction of the triangle's side. Gonna rotate it. Actually, I don't even have to do this myself. I can do rotate vector like this. I can do rotated back equals rotate vector. And this should be going counterclockwise. So I'm going to want to do negative pi. How's the animation go making use of the new features? Yeah, it makes it a lot faster, actually. It's really nice. Okay, so now I have this rotated vector. I want to normalize that. So now I have this. Triangle normals are going to append a rotated vector. Great. And now, oh, that's going to crash. Wait, where did that crash? Point inside triangle. Okay. Wait, where did that crash? Point inside triangle. Okay. So this line, now I'm going to add an arrow. I'm just going to start triangle here. That'll be the start, or rather, triangle points at -1. That's the start. And the end, triangle points at -1. And I'll add that rotated vector, which is the normal. I could do triangle normals at -1. Okay. I think it worked. Or did it? No, it's parallel to all of them. It's parallel to all the sides. So it's like the rotation never happened. End minus start. Then I did rotate vector of vec -pi. Also, why is... Oh, I'm not appending to triangle points. Or triangle points isn't growing here. I should do triangle points at I. Yeah. Then triangle points at I. Plus triangle normals at -1. No, I must have broken this again. Oh, no, it was just taking a long time. And this is still not the normals. I don't get this. It's like the rotate vector isn't doing any rotating at all. Like, what happens if I don't do rotate vector? I just normalized the vector. I just added that. So here they're going along the side of the circle. Oh, I did by -pi. Should have been -pi/2. Are these normals? Oh yeah, these are normals. They're just going the wrong direction. So I guess I'm gonna do +pi/2. It's taking a long time because I'm doing this. I'm doing this in this pretty large loop. Probably don't have to, but I am. Okay, so now I'm just gonna remove this add. I won't be adding all these squares. Okay, but now I got the normals for each side. Okay. What I actually want to know is the point inside the triangle. So to do that, I'm gonna have to translate the start point to the origin and then dot the two of them. I think. The idea here being that come on.